Hello guys, today we're going to learn how to graph the data that you guys collected for your Friction Lab number one. So the best thing to do is go into your Google Drive, click on Google Apps, and from here you should be able to click on New and then go down to Google Sheets, and this will open up a brand new Google spreadsheet. I've already loaded one, so I'm going to go ahead and click on it. The first thing you should do always when you get into a Google spreadsheet is change your title, rename it. I titled mine Friction Lab 1 Data, and then I put my name in there. So as you can see here, we have force of sandpaper in newtons, force of carpet in newtons, force of the table in newtons. These are going to be our titles. We don't want any titles next to our number. So like when you guys were recording your data, you put like 1.5 newtons or 1.4 newtons. We want to have newtons in our title, but we do not want them in our spreadsheet because the data cannot be registered. It doesn't understand what N stands for it. And actually, it thinks N is a number. So by putting an N in there, we will actually cause confusion. So we want a title at the very top in newtons. Over here in column A, we're actually going to make our mass as our independent variable because we are changing the mass every single time we drag it over these different surfaces. So we measured this in grams. Okay, so I'm just going to put mass G, and to kind of make it a little bit nicer and cleaned, I'm going to go over here to the alignment and just put everything in the alignment. If you want to, you can also bold it, makes everything look a little nicer, and then you can double hit in between each of the boxes to make everything spaced out a little bit better so it doesn't look like it's scrunched up, like so. And so now I'm just going to go down through here and put in data. So our mass, we increased, you had to measure the block by itself. So I measured one of the blocks and I had 100.5. Then I had 150.5. Then I had 200.5. Then 250.5. And then my last block was 300.5. And then the force of the paper, of the sandpaper, as I went down or across. So it would be 0.6, then 1, 1.4, then 2, 2.5. I'm not going to put in here my static force. I'm not worried about that right now. I'm just worried about graphing the initial data. We'll talk about the static force later on. For the force of the carpet, I had 0.2, I had 0.4, 0.6, 0.8, and 1. And then for the force of the table, I had 0.1, 0.2, 0.3, 0.4, 0.5. So now I have this data and I can actually graph the whole thing by going up to the upper left-hand corner and set box 1A, scrolling all the way across to 1D and down until I have that entire row 6 covered. Then I can come over here to insert, and what I'm looking for is chart. And so I'll hit chart, and it will load a chart for me eventually. It's working up here at the top. There it is. And again, I don't like how this originally forms this information. This is just graphing mass, and I'm not able to see anything. So I'm going to change this chart to a scatter plot. Okay, and then I'm going to have to change some things around so that I can switch some stuff around. So if I click here where it says use column A as labels, now we see, for example, this is my grams, 100, like these are grams going across the bottom here. And then what's in, for example, yellow is going to be the force of the table. Then what's in red is the force of the carpet, and what's in blue is the force of the sandpaper. And we can see that these formed somewhat what looks like a line. However, we're going to play around with this a little bit more and hopefully get it so that we can kind of clean this up a little bit, change some things around. So we got to go to customize. All right. And if you look right below your chart, you'll see that you have to graph the following. You have to use Google Spreadsheets. So we're currently using Google Spreadsheets. You have to use 3 different colors. We have 3 different colors: blue, red, and yellow. We have to make a scatter plot. We did that. We set this up as a scatter plot right here. We need to use trend lines and R-square values. So trend lines is going to be in the customize. We got to go to series. If you want to change any of your point shapes, you don't want, if you want stars or anything like that, you can have stars. If you want to change their point size, you can change their point size. But here's where trend lines come in. So I'm going to click on trend line, and notice that we have some of our points that are not on the trend line. They're just below. This one's directly at the trend on the line. This one's slightly above. This one's slightly above and slightly above as well. So to see how well our data fits that line, what we need to do is we need to come down here to where it says R squared value. So we're going to click on this. And what we're going to notice is that there's going to be an R squared value for all of these different forces, for the force of sandpaper, for the carpet, for the force of the table. All right, so watch this. I'm going to click here and notice that we end up getting R square values that are either 1 or less than 1. And with the sandpaper, it's at 0.993, which means that 99% of our data fits this line, okay? Which is like a golden rule. If you get that in science or in math, like, you've got something, okay? And then for the force of the carpet, if we look here, we see that it's exactly 1. Same thing for the force of the table. It's exactly 1. Now, I'm eager to find out what you guys have for your data, but what this is saying is that there is a true cause because of what happens when we increase our mass, how much force we need in order to move that object. There's a correlation going on here, which is amazing. And that's something that we're trying to look for. And so some things that we need to do next would be label our X and Y axis. So we're going to go back over here to where it says charts and axis. It's the second one, titles. And I'm going to change the title. So I don't want this whole mass, whatever, force, sandpaper. We want to get rid of all of that. So we're just going to go ahead and delete all that. And I'm going to change it to something that makes sense. So what we're doing is we're looking at basically the amount of force required to move over 3 different types of surfaces. So we could say force in newtons required to move over 3 different types of surfaces. So that makes a little bit more sense, okay? We can actually align that, put that right in the middle. We can bold it, make it look a little nicer, okay? And then we can actually go back into it if we want to as mass is increased. Okay, so now we have a nice little drawing and everything kind of works out for the best, but we need to change our X and Y axis. So our horizontal axis, this is what we're going to see. This is our mass, and we're going to have grams. And then our Y axis, which is our vertical axis, we're going to change this to force, and that's in newtons. And notice this is our graph. And so what you're going to end up doing is, I would say, to maximize your graph, make sure that it's the biggest you can get it. We can come over here and make this a little bigger, okay? Um, Fill it in with the whole chart. If you wanted to, down at the very bottom, with your horizontal axis, you could make your horizontal axis the scale, okay, longer, so that this 300 right here is actually a little bit beyond that. So it's like 350, okay? Um, and then this over here where it says 2.5, we could make it go up to 3 if we wanted to. So that's something that you can also play around with, like where it says maximum value for the vertical axis. We could just type in 3 here, and it should change it a little bit. There it is. So see, you notice it changed it. And then for the for the horizontal axis, we could change the maximum value here to like 350. And now notice that it kind of goes out, and we're foreshadowing like what it would look like. And so now it kind of makes it a little bit more cleaner so that these little data points aren't lining directly up along the edge of the graph. And this looks really nice. Okay, so I would consider this a done graph that's showing all of our data that we can then interpret and answer questions. Hopefully this helped.